Okay, so let's discuss a question from theory of machines. So you have a link which is given and which is hinged at O, and it can move about O, so it can undergo a rotational motion about O. So about O, the angular velocity is given. So this is my angular velocity omega. And now the acceleration at point P, it is known that relative to O it is 45 degrees to OP. So this is OP and that is 45 degrees to OP. So the acceleration of point P is given like this. So this is the total acceleration and this is 45 degrees to OP. So let's draw like this. So this is the direction of OP. Okay, and you have the acceleration like this. This is 45. Okay, so now we know that any point on a link, okay, and the link is undergoing a planar motion, it's basically undergoing a circular motion. So point P is undergoing a circular motion, OP is undergoing a fixed axis rotation. So point P will move in a circle. Any point moving in a circle will have both the tangential acceleration, which is tangent to the path, and the normal acceleration passing towards the center of rotation. So tangential acceleration and normal acceleration, the resultant of that is A, which is given as 45 degrees to the OP line. Okay, so this is your tangential acceleration, this is your normal acceleration, and this is your A. So this is your this is 45 degrees, basically 45 degrees with the horizontal, 45 degrees with the vertical. This is also 45. So now we need to get the equations. Now what is tangential acceleration? When a point moving in a circle, the point P is moving in a circle, the tangential acceleration is given as r alpha and the normal acceleration is given as r omega square. So these are equations which you get from kinematics. Okay, so tan 45, so tan 45 is nothing but from this diagram it's basically an by at, and an is r omega square and this is r alpha. So it is basically tan 45 is 1, so it is omega square by r alpha. So alpha is nothing but angular acceleration that we get as omega square. Now remember that why we got this, we just use one simple condition that the acceleration vector is along making 45 degrees to OP. Now you have to get the motion of P. P is moving in a circle, so it has tangential and normal acceleration. The resultant of tangential and normal acceleration is the total acceleration A, which makes angle 45. So then we just write in the vector diagram and we get alpha is omega square. Now omega is given as 5, so it is 25 omega square, which is 25 radians per second square. So alpha is 25 radians per second square. So it's a simple problem, just you have to know the basics of circular motion. So 25 radians per second is the answer. Thank you.